I'm never gonna get this web assignment done. This is my final try. Hope this works. Come on, we're on again. Hello?
Neo, listen to me carefully.
Who is this?
Just listen, I'm going to help you solve this problem.
How do you even...
Just first, solve the equation for y. We're going to get y equals 2x minus 3. Substituting this value of y into the second equation yields 4x plus k times 2x minus 3, which equals 4. Once you solve for x, you get 4 plus 3k over 2 times 2 plus k. Since x is not defined when the denominator of this last expression is 0, we conclude that the system has no solution when k equals 2. Do you get that?
I got it, but how do you even know it's right?
You just need to enter that solution.
I will, but can you at least tell me who you are? That was so weird. Jeez, were you the guys on the phone? Who are you?
Follow me.
Why would I just... Doesn't make sense. You guys... Well, if they did know how to do the math problem... Wait!
We're here to tell you about something called the matrix.
Your entire life you've been living a lie. You're born into a world which solves systems of equations with substitution. This is not how it's solved in the real world.
Why are you telling me all this? I was perfectly happy in my world of substitution.
We believe you are the chosen one.
The what?
The chosen one. We've been looking for someone to solve this problem. The fate of the human race depends on it.
What? I can't solve that. There's 8 variables. I'm barely passing math. This question's ridiculous. It would just be a mess, and it's a waste of time.
You only think you can't solve this, but that's because right now, all you know is substitution. Morpheus thinks you're the one. If he's right, then once you fully understand how to manipulate the matrix, these problems will be no match for you.
We'll see you at training tomorrow morning.
But...
Welcome. Are you ready to begin your training?
Let's do it.
Okay, let's get started.
Before we get started, we want to make a few observations. If I gave you these equations and asked you to find x plus y, how would you do it?
Well, I would add 5 and 6, so x plus y equals 11.
Right. Did you notice that to do that, you added these whole equations? On the left-hand side, you added x plus y to get x plus y, and on the right-hand side, you added 5 and 6 to get 11.
Oh yeah, I did.
So we can add equations together to get new equations, which will also be true. What do I get if I add these equations?
Well, there's an x and another 5x, so 6x, and 2y, so 6x plus 2y equals 14.
That's right. Notice that to get the coefficient of x in the new equation, you added the 2 coefficients of x in the previous 2 equations. The coefficient of x in the first equation is 1, and the coefficient of x in the second equation is 5. So to get 6x, you added 1 and 5.
Oh yeah, I did.
We can streamline this process by using matrices. Here, a row represents an equation, and each column corresponds to one of the variables, with the last column, called the augmented column, representing the other side of the equal sign. A system of equations written in this way is called a matrix. Now, to add the first equation to the second equation, all we have to do is add the rows.
I see. If we add row 1 and row 2, we get 6, then 2, and then 14 in the augmented column. So this means 6x plus 2y equals 14?
Yes, exactly. Now that we can see how adding rows works, let's take a look at what a solution matrix looks like. So tell me, what system does this matrix represent?
Well, there's 3 columns now and 3 rows.
Right, so we'll need a third variable now. Let's call it z.
Oh, okay, I get it. So then 1x plus 0y plus 0z equals 3, and 0x plus 1y plus 0z equals 2, and 0x plus 0y plus 1z equals 8. So I guess that's the same thing as saying x equals 3, y equals 2, and z equals 8.
Yes, exactly. So if we can figure out a way to make a matrix look like this, then we've solved the system of equations.
Oh yeah, cool. So how do we make a matrix look like that?
Well, we've already seen that we can add equations together to get new ones. There are 3 row operations we can use on matrices. 1. Multiply one row by a constant. 2. Add or subtract a multiple of one row from another. Or 3. Exchange 2 rows with each other. Let's consider our previous example. We can use the matrix operations to solve the system of equations. We want to try to get a 0 in the lower left-hand corner. This will get rid of any x's in the second equation, leaving only y's. We know we will still have a true equation if we multiply the first equation by -5. Let's write r1 to mean row 1, or equation 1, and r2 to mean row 2, or equation 2. So then, -5 times r1 gives us this. Then notice, if we add -5 r1 to r2, we get this. Notice that -5 r1 plus r2 has a 0 where we wanted a 0. So we can replace the old r2 with this, and we get this. So, now we want a 1 where the -4 is. This will make it so that the equation corresponds to y equals our solution. How do we do that?
Multiply row 2 by -1/4?
Yes.
Oh, I see. And this is our new row 2?
Yes. So, now we want a 0 where the 1 in the upper right-hand corner is. This will get rid of any y's in the top equation. How can we get a 0 there?
Can we subtract row 2 from row 1? I don't know. Is subtraction allowed?
Yes. Subtracting 2 rows is just like subtracting 2 equations, so it's allowed.
Okay, so 1 minus 0 gives us 1, and 1 minus 1 is 0, and 5 minus 4 is 1. Oh, and this is our new row 1?
Yes.
So then we're done. X equals 1 and y equals 4.
Let's check our work. To do this, we recall our original equations. Then we put in 1 for x and 4 for y. Does our answer work?
Yes.
As a review, remember that the 3 operations we are allowed to perform. Now you're set to solve bigger systems.
Wow, these matrices are so much easier. I never thought I'd be able to do this.
Oh no, I thought we had more time.
Who is that?
Just keep working, I'll get it.
Mr. Anderson, wouldn't that problem be easier with substitution?
No.
Now, Mr. Anderson, won't you be a good boy and try substitution?
Well, I would, but I'm all finished.
What? Oh, matrix elimination is ruining my life.
I wouldn't substitute this for anything.